On behalf of all assembled here today, I should now like to invite our newest alumna, Dr. Charlotte Fischer, to address Convocation.
Chancellor Coward, President and Vice Chancellor Chakma, distinguished faculty, graduating students, family, and friends. It is an honor and a privilege for me to be here today, all the more so since I have no direct connection to your great university. I come to you as a woman scientist and a retired academic. It's unbelievable in a way, but 20 years ago, I gave up teaching and began finishing the many projects I had started. At the same time, I continued research by collaborating with former postdocs. Many of my fellow residents in retirement play bridge, do crossword puzzles. I do research. But I'm also here as an immigrant. I was 6 months old when my parents landed at St. John, New Brunswick, fleeing from the Russian Revolution. It was the height of the 1929 Depression. Duncan Mackay and his family welcomed us to their home in Aberdeen, Saskatchewan. Father worked on the farm, mother in the house. Over a period of 4 years, they managed to save $150 that they used as a down payment for the purchase of 10 acres of virgin land near Chilliwack, BC, in the Fraser Valley. This is where I grew up. I, of course, remember virtually nothing of those early years, although I do remember the poverty. The only book in our family was the Bible. Going to school opened a whole new world to me, particularly in high school when the school bus took me to Chilliwack and I discovered the city library. For me, school was like a vacation. Life today is very different. Given the ubiquity of technologies and the rapid rate of change, fundamental skills in science, technology, engineering, and mathematics are needed for many future career paths. Artificial intelligence is now sufficiently well understood to where it will greatly affect our lives in the near future. Society needs innovative ideas from everyone, including those of women. So how did I become a woman in science? When I went to university, I wanted to be a bacteriologist, but I soon found that half the class was better than I was. Aptitude tests had always indicated that I should study mathematics, but I did not see math as leading to a job I wanted. However, I also felt that I should pursue a subject in which I could excel and decided to double major. Math because it was easy, chemistry for my future. Yeah. No, where was I? Over time, a professor of the math department convinced me that if I was good enough, there would be a job for me. Upon graduation, I went to Ottawa as a summer student in mathematics. I spent the entire summer in front of a desk calculator. The experience convinced me that if mathematics meant computing, then I should study computers. My supervisor was from Cambridge University and suggested I write to Douglas Hartree, who is well known for his interest in computing. So off I went to Cambridge to study the most advanced computer of the day, the EDSEC. Before leaving, I had applied to NRC for a scholarship to study abroad. I got the scholarship, but to my surprise, it was valid only in Canada. Somebody had made a mistake, but no, I was denied. At that point, I took out a loan and stayed in the UK for 2 years, just long enough to satisfy the residence requirement for a Cambridge PhD. I finished my thesis at the Computation Centre of the University of Toronto. It was there that I met Beatrice Worsley, who had preceded me by 5 years at Cambridge University and is, in my view, Canada's first computer pioneer, male or female. She died suddenly in 1972 at the age of 50. Like so many women, she did not talk about her achievements. 30 years later, I learned she had studied with individuals who today are leaders in the technology field, including 3 months with Alan Turing, known from the popular movie The Imitation Game, but also the first to write about computers and intelligence. In my days at Cambridge, the question was, can computers think? For which the answer is no. Computers do what they're told. But Turing changed the question to, can computers exhibit intelligent behavior? Which now seems to be yes. I hope Trixie will be honored at the new Museum of Science and Technology in Ottawa in due course. There were few job opportunities for when I completed my PhD, but I received an excellent offer from the mathematics department at UBC, and that is how I became an academician. Their computing center had just purchased a computer. I participated in their activities and introduced numerical analysis courses into the mathematics curriculum, so teaching could overlap with my research interests. In those days, each computer had its own, quotes, language. The summer of 1960, I had the opportunity to spend a few months at the Boeing Airplane Company in Renton, Washington, just 150 miles south of Vancouver. They had the latest IBM 7090 computer, also the first Fortran compiler. The latter supported a universal mathematical language, and I saw immediately that it provided an opportunity for a portable research project. And indeed, the next summer, I was invited to the Harvard College Observatory, where they also had an IBM 7090. So I started a project for predicting atomic properties. My research was funded for 30 years by the US Department of Energy. One of the most ambitious energy projects in the world today is the ITER project, aimed at generating clean energy by a process similar to the way it is produced by the sun. Many countries in the world are members of ITER. Europe, Russia, China, Japan, USA, etc., but Canada is not a member. My work on calcium minus that was mentioned was a serendipitous discovery. In those days, it was believed that elements in the second column of the periodic table could not form negative ions. Professor Vasco and his postdoc, then at the University of Toronto, were using density functional theory to compute scandium minus. I decided to try some calculations of my own and observe the role the 3D electron played in predicting the electron affinity. Scandium is adjacent to calcium in the periodic table, so it occurred to me that maybe the same was true in calcium. In fact, it was. We wrote a paper and published it, submitted it to the most prestigious journal in physics. The paper was rejected. Nobody wanted to believe our result. We resubmitted, but it was rejected again. So we had a choice. We could go to another journal. I decided to wait. Sure enough, in less than 3 years, there was an experimental paper which predicted an electron affinity very close to mine, and of course, our paper was published. This is a good example of the role of computation in physics. I believe strongly that computation can replace experiment in many situations and often costs a lot less. A few weeks ago, we heard the exciting news that Donna Strickland from the University of Waterloo was the third woman ever to be awarded a Nobel Prize in physics. It was for her work on lasers, and surprisingly, the first paper she had ever published. She got interested in laser physics already in high school. She compared her situation with that of Maria Goeppert-Mayer, the second woman granted the same prize, but back in 1963. Because of anti-nepotism in those days, Maria was often unpaid or given a job as assistant because her husband was also on the faculty. Dr. Strickland always had a regular position with a salary and cited this as an example of the progress that has been made in the last 50 years with regard to women in science. I believe there are other examples as well. So, members of the graduating class, in comparing my graduation with yours, you will see that there have been tremendous changes. Anticipate further changes and plan for a lifetime of learning. Here is another factor to consider. In 1950, the longevity for males and females was 66 and 71 years, respectively. So it made a lot of sense to take retirement between ages 60 and 65. According to Statistics Canada, for 2018, the ages are 80 and 84. So retirement age needs to change. Individuals age in different ways, and more are becoming centenarians. Googling the internet, I found, to my surprise, that education is one of the strongest predictors of life expectancy. What does it mean? Statistically, educated individuals live longer than those less educated. My congratulations to the graduating class for your achievements to date. Go out into the world, make your parents proud, and make this planet we live on a better place. Also remember, you may live to be 100. My best wishes to every one of you.